Okay. Now we want to rotate over a vertical axis. And if we still want to have discs or washers, we're going to have horizontal rectangles. Okay? So I'll have you notice these rectangles are perpendicular to our axis of rotation. That is how we're getting these discs and washers. Okay? Oh my goodness. Weird. Okay? So, how are things going to change?
Not much.
Not much. What's going to look different about our setup?
It should be Y.
There's going to be Y's instead of X's, and instead of top to bottom, we need to think of right to left.
Hard and right.
Huh?
Hard and near. Somewhere.
Right. Biggest radius squared minus smallest radius squared, whatever that may be. To find each radius, we will use our right minus left concept. Okay, but the biggest radius has to come first. Okay, some of you got some negative volumes yesterday. That's because your radii have been switched around. Okay, you did small minus large, which is why you got the same answer but negative. All right, so please be careful. If it happens again, that should be assigned to you. I set this up incorrectly.
But can there be negative
Negative volume? No. There will not be negative volume. Okay. So we're going to do a couple examples. We will rotate over the y-axis a couple times, and then we'll rotate about a line that isn't the axis. Yes, sir.
It never shows those like animations yesterday that Brady was talking about.
Yes, I did.
Yeah,
There were like 3 of them.
the stadium one.
Yes, that was the very first animation that we saw.
I didn't see no stadium.
I don't remember it.
I remember it.
Don't go find it for him.
It's too late now.
Whatever happened to the number so we could see the number slide now?
Yeah.
Because I'm using PowerPoint instead of Smart Notebook.
I would rather have slide notes.
We gotta go back.
I would rather have Smart Notebook too, but I can't have these animations in Smart
So
Notebook.
that's the stadium.
If you like this,
Not really.
then yes, it looks like a stadium.
I thought it was an actual like
Yeah, so did I.
stadium.
Freeball had a different one. It was
How
like,
would that work?
it was like upright.
It's like-
and it's
Oh,
like-
Freeble had a different one, so this isn't the same thing that he did.
It's not. No, I think this is real.
Yeah. I know it's.
Okay, write this example down. Y equals 2x squared. What is that?
Just skinnier.
A skinnier parabola. Y equals 0 and then x equals 2. That look about right? I didn't draw the rest of the parabola because it doesn't matter. What?
2, 4. Or
2.
like what's the top one?
What is that coordinate? This coordinate would be 2, 8. Okay? Now, if, okay, so first of all, we are rotating about the y-axis. So we're getting something that looks like this. Let's just imagine if you tried to draw a vertical rectangle. Is that going to rotate around to make a disc or a washer? No, that's not going to work. We don't know how to do that. This is what we'll do next week. They're called shells. Okay? So we don't know how to do that. So instead, we're going to have to make
So would our integral go backwards then?
No, it's not gonna go backwards.
So 0 to 2?
Yeah, well, no, because now we have horizontal,
Oh, so.
rectangles, and so they have thickness dy. Okay, so let's think about, our integral here. We're still gonna have pi r squared h, but now we're talking about dy. What would our limits of integration be? 0 to 8, because we're talking about y. Now, before we pick out our two radii, well, I guess we really have to worry about y equals 2x squared. What do we have to do with that? Okay, it has to be in terms of y, so we need to solve for x. So y equals 2x squared is the same thing as y over 2 equals x squared. Technically plus or minus the square root of y over 2, but what piece are we working with, the positive or the negative? We're working with the positive. So this piece right here is x equals positive radical y over 2. Okay, so let's think about our radii. Axis of rotation to the furthest away, and axis of rotation to the closest. So we have the black radius and the green radius. Which one's larger?
Black.
The black one. From right to left. What's our right function? 4 minus 0 squared.
It'd only be 2 minus 0 squared.
Oh, who said 4? Okay. Instead of like first, okay? Then we can do whatever we want. Minus smaller radius. From right minus left. Square root of y over 2 minus 0 squared. If you don't have the minus zeros, that is fine.
Wait, what are my zeros?
The y-axis.
Because our axis of rotation is the y-axis.
Yeah.
So right minus left, we have 2 minus 0.
Oh.
Because we're at position x equals 0.
We just plugged in the equation for.
Which is going to be the same thing. This is the same thing as.
Oh,
Two
you're
squared
including the possibility of the rotation axis. Okay.
Right. See, yesterday when we did the axis problems, we didn't know we could do it over a different axis. Now we have that knowledge, so I'm throwing the 0 just to keep everything straight. Okay? Now this one would be very doable by hand, wouldn't it? Because this is just 4 minus y over 2, y squared over 2. No y over 2. My goodness, this one is y over 2 dy. So pi times 4y minus
Y squared.
because it's 1/2 times 1/2 y squared.
So our answer is
8 times 4
14.
minus 8 squared divided by 4 minus 0. So what's our answer? 16 pi. Okay. Ready for another one? Okay.
Why do you-
Okay, so our picture.
Is it another teardrop problem?
Well, kind of. It's a different teardrop though, but it still looks like a
Could you
teardrop.
just
Right?
zoom in on
Yes. So this is.
Could you do the magic pen and do please? Take one picture.
Oh no, because this isn't smart notebook.
Oh my
I know this is
She was gonna
disappointing.
do it too.
I was gonna entertain you. Okay, so we're talking about this piece in quadrant 1, and we want to rotate it about the y-axis to get something like that. Okay, and if we want discs, or in this case washers, we need a horizontal rectangle. Okay. What's the thickness of that rectangle? dy. Why is it dy? Because the thickness matches up with the y-axis. Okay, so we have pi times our integral from
0 to intersection.
and what is this intersection point?
That's a very good question.
Where does the square root of y equal x squared? 1. Okay, so now, both of these equations are in terms of x. We want them in terms of y. X is plus or minus square root of y. So what piece are we talking about right here? Okay, so this piece is positive radical y, and then x equals y squared. That would be this one. Okay, so we're going to have, from our axis of rotation to our function, here are your two radii. Which one's larger? The blue, so that's the first one that we need. Right minus left. Right minus left for the larger one is what? Square root of y minus 0 squared. Minus y squared minus 0 squared dy. This also would be a very nice non-calculator problem where I could ask you to integrate it.
On a non-calculator portion.
Yes.
So even though like that one's in terms of y, like it's x equals y squared, you can just like subtract, like because like that horizontal line, that's x equals 0.
Right. And all of our other equations are x equals square root of y, x equals y squared. Okay? Anyone punch this in their calculator? What?
35.
If you put 0.3 pi, I will not be happy.
We can count it.
But it's still
But
right.
you have to count it because it's
30%.
I have to.
Yeah.
What about 30%?
30%.
A fraction with as a coefficient of pi, or multiply the pi through and then approximate it. Those two ways. Last problem.
Whoa.
Someone's being nice today.
So, what's true about this problem compared to the last one?
Same thing except for birthday about it.
Yes.
Oh my wow.
okay? Here's our reference rectangle with thickness dy. So, notice what happens when we draw in our two radii. Okay, so from function to axis, axis to function.
Oh, they switch.
Why do they switch? Because we're rotating about an axis that is on its right side. So we are rotating around something that was on the left. Now we're on the right. So all you have to keep track of, right minus left, right minus left. So when we set this up, our limit of integration is still 0 to 1. The height of all of these washers is still dy. Let's talk about our outer radius. Which one is larger?
The y squared.
How about this, green or blue?
Blue.
Blue. Right minus left. Right would be
10
minus.
Square third y squared.
So there's big radius squared minus small radius squared. So from right minus left,
10 more.
10 minus small radius squared.
Okay, I'm still really confused about like when it's 10 minus or function minus 10.
Okay, we have to go right minus left. So since this axis of rotation is on the right side, we have to say right minus left. Okay.
It's the long right minus left and the short right minus left.
Yes. And don't forget that each individual radius has to be squared. It is radius squared minus radius squared. So I will give you an opportunity to begin your homework. That way you can kind of think through these problems with me here. So page 453, 7 through 10, 11, B and C. You can throw D in there if you'd like. Since you didn't get to do it last night. Tomorrow we're going to talk about volumes of cross sections, and then we'll review Thursday for our quiz on Friday.
Can you go back to the previous slide?
Wait, what's the answer to that?
The final word.
No word is not allowed in my classroom, sir.
Yeah, seriously?
That's 2 words.
Can I, actually?
I don't need you talking back.
Wait, what was the answer to that one?
20.00,
Would it be?
So I'm guessing it's 20.001.
yes.
Multiply by pi?
That's already.
That's good, multiply by pi. Okay. Yeah, this one you're not going to get a nice fraction because you have an irrational, like you're going to get irrational values with that square root of y. Okay, real quickly, Brady, you needed to look at this.
The previous slide, yes. Oh, I thought we finished it. So, don't you still have to integrate it? So would it be like?
We did integrate it. That's the 3 pi over 10. We used our calculators to integrate it.
Okay.
We did the first problem by hand.